Greetings. Today we're going to learn about the properties of logarithms. In this video, you will not be able to fast forward and you will not be able to jump ahead. So you'll have to take notes as you go along. Some of these problems may be familiar, so they might be pretty easy for you, but at the end of each section I will be having a check for understanding. So you'll be able to answer a question and I'll be able to see what you choose as an answer. They will not be graded for correctness, they're just for you, purposes are just for you to check your understanding in each section. So let's get right to it. Change your base formula. So if you have a logarithm of any base, let's say base a of b, change your base formula allows you to rewrite that as a log base 10 of b over log base 10 of a. It also allows you to write it using natural logs. Now this is an important formula to note how to use because in your calculator you can only type in log base 10, that's the log button, or natural log, that's the ln button. And it's a good thing you can use either one, just as long as you're consistent between the top and the bottom. So I can evaluate log base 4 of 30 as either log 30 over log 4. Okay, and typing that in your calculator, you get something like 1.477121255 all over 0.60205 Or you can evaluate it using natural logs, natural log of 30 over natural log of 4, which gives you 3.4011973 2 all over 1.386294361. Either way, when you divide those out, you get log base 4 of 30 ends up being approximately 2.453445298. And depending on how the question words how I want you to leave your answer, say nearest thousandth, your answer is going to be just 2.453. Go ahead, just maybe pause the video now and try the next one before I even show you how to do it. Okay, hopefully you just tried it. If you use natural logs, it would be natural log of 14 over natural log of 2, or you can use log base 10 of 14 over log base 10 of 2. Either way, you should end up with a value of 3.807354,922, etc., etc. Goes on. So to the nearest thousandth, log base 2 of 14 is going to be 3.807. Here's a chance for you to check for your understanding. So on the right side, you'll see some answers in a moment, as soon as I finish explaining this. So I want you to use either natural logs or common logs to find out the value of log base 6 of 82. Okay, let's go on to the next section. Now, some more properties of logarithms are the multiplication property, the division property, and the exponent property. Now this works for natural logs, logs of base 2, log base 10, any kind of log. So if you generally have a log of two things being multiplied together, say log of a times b, what you can do is you can break that up into a sum of two logs, log a plus log b. Because if you remember what I said yesterday, logs are essentially exponents. And when you multiply the same base together, say x to the a times x to the b, that gives you x to the a plus b. So when you're multiplying two things within a log, you separate it into a sum of two logs. Division, where you have log of any base of a over b, what you're going to do is you're going to subtract them. Just like in the exponent rules, if you are dividing like bases, you'd subtract the exponents. And the final property is the exponent property, meaning if you have a log of something raised to some power, what you do is you write it as multiplication. And what we're going to do is we're going to bring that power out front to leave us with b times log of a. And those are the three properties of logarithms that we're going to apply in number 2. And in number 3 and in number 4. In number 2, you can apply these properties to find the log of any kind of a base of a number if you know some parts of it. Because if we know log base a of 7 is 1.209, log base a of 3 is 0.683, and log base a of 2 is 0.431, all I have to do is, for each of these problems, for a, b, and c, find some way of representing those values in terms of 7, 3, and 2 with either multiplication, division, or using any kind of an exponent. So notice the exponents don't have to be a 2, 3, or 7. It could be a 4, it could be a 6. 21, using the values 7, 3, and 2 to represent 21 with multiplication, division, and our exponents, you might be able to see, well, I can represent 21 as 7 times 3. Using the product property, the multiplication property, I can rewrite this as log base a of 7 plus log base a of 3. Notice it doesn't matter what log base a is or what the value of a is in the base. We know log base a of 7 is 1.209. That's our given. And we know log base a of 3 is 0.683. And when you add those together, we get 1.892. That's the approximate value of log base a of 21. Looking at letter B, you have to find some way of using the 7, the 3, and the 2 with multiplication, division, or exponents in order to rewrite 8 as something. 8 is 2 cubed, or 2 times 2 times 2 as the product. So I can apply actually if I write it as 2 cubed, then I can use the exponent property. By bringing that 3 out front to leave me 3 times log base a of 2. And we know from the given that log base a of 2 is 0.431, so it's really just 3 times 0.431. And when you multiply that out, we get 0.862. And my answer key is actually wrong. It's not 0.862, and you should be able to see that. It is actually 1.293. So I'll have to change that on my answer key. My apologies. But 3 times 0.431 gives us the value of log base a of 8. In this last example, we got to find some way of rewriting the 9/7 as a product, division, or exponent involving the 7, 3, or the 2. Well, clearly in the bottom we're going to have 7 in the bottom, but 9 can be 3 squared. So I'm going to rewrite this as log base a of 3 squared over 7. I'm going to be applying both the division property as well as the exponent property. Let's do the division property first. So this becomes log base a of 3 squared minus log base a of 7. And then using the exponent property, the 2 goes in front of the log base a of 3 to give me this. And now I have something I can plug into. Log base a of 3 is 0.683, so it's 2 times 0.683 minus log base a of 7, which is 1.209. So it's going to be 1.366 minus 1.209, which gives me 0.157. Now all these examples ended up being positive values, but keep in mind that the range of log functions is all real numbers, so you actually could end up having negative numbers. Just keep that in mind. So here's a chance for you to check your understanding on this section. So please find the value of log base x of 54 given log base x of 2, log base x of 3, and this should say log base x of 5. Alright, let's continue with the properties of logarithms. So what we want to do in these examples, in number 3, is to use those properties to rewrite the logarithms as a sum or difference of logarithms. So in letter A, notice we have a bunch of things being multiplied together. That means we're going to be applying the sum, or the division, the multiplication property. So I can rewrite this as log base 5 plus log 5 plus log x cubed plus log y. I can also apply the exponent property to bring that exponent in front of that log base x to give me log 5 plus 3 log x plus log y. And there's my sum of logarithms. In letter B, we have a fraction, so we're going to be using the division property. And notice we also have the square root. And remember from last year from square roots, we can represent these with fractional exponents because it's the square root. It's going to be 1/2 as an exponent. So there actually is an exponent property we're going to be applying here. Okay. Let's first deal with the division property, which says we're going to take this and make it natural log of 3x minus 5 to the 1/2 minus natural log of 7. Now applying that exponent property to bring this 1/2 up front, it gives me 1/2 natural log of 3x minus 5 minus natural log of 7. Don't forget to put the parentheses around the 3x minus 5. Okay, because in this case we have a binomial, and if you don't put the parentheses there, it's just going to look like natural log of 3x minus 5, and that's not what we want it to look like. So now is a chance for you to check your understanding of that part one more time. So take a moment now and rewrite this following logarithm as a sum or difference of logarithms. Alright, this last section talks about condensing these following expressions into one single logarithmic quantity. To do that, we have to look to see what we have pluses and minuses and when we have numbers in front. Because if we have a number in front, like we do in letter A, we have the 1/2 and the 3, those are going to become exponents. When we have a subtraction between logs, that's going to mean we're going to have division. Now keep in mind, even though there's an addition here, this is not going to break up into the product of logs because in this case it's in parentheses log base 2 of quantity x plus 1. So I see essentially two parts here, two main parts. Using the exponent property, I can rewrite this as log base 2 of x to the 1/2. Now, notice I could just go right ahead to, instead of just log base 2 of x to the 1/2, I can do log base 2 of radical x, because an exponent of 1/2 will give me a radical x. Minus log base 2 of x plus 1 cubed, because that 3 becomes an exponent. Notice I now have it just in terms of log base 2's. And I have the subtraction. So if I combine it further into one final logarithm, it's going to be log base 2. And it's going to be division because you have the minus sign. Radical x over x plus 1 cubed. And there's your final answer. Let's go to letter B. Now in this case I have a plus and a minus. So the two things that are being multiplied, every time you see a plus in front of a log, it's going to be in the numerator. When you see a minus in front, it's going to be in the denominator because you're dividing by it. So this becomes, using the exponent property, it becomes natural log of x to the 9th plus natural log of y minus natural log of x minus 3 to the 5th power. Now these first two are being added together, so once I combine this into one big logarithm, one single logarithmic quantity, I'm going to multiply the x to the 9th and the y, because you're adding those two logs together, and I'm going to divide everything by the x minus 3 to the 5th power. And there is my single logarithmic quantity. Okay, letter C. So I'm going to combine them after we find out what we get after using the exponent property. So we get natural log of x plus 2 squared plus natural log of x. And then we have the subtraction, so it means we have to use the division property. So we have natural log of x plus 2 squared all over x. Alright, and this last one, notice I have the brackets. That means the 4 is going to end up being an exponent to both the first log there and the second log there. So if you can imagine distributing that 4 through, then it's going to be an exponent of both those log expressions. And subtracting off one logarithm at the end. So that means, let's distribute that 4. Let's do that. Let's make this 4 log base 3 of x plus 4 log base 3 of x plus 5, and then subtract off the 2 log base 3 of x minus 5. So two things being added together, so that's going to become, in the long run, a multiplication of x to the 4th, as well as with x plus 5 to the 4th. Okay. And we're going to have x minus 5 to the 2nd power in the denominator. So let's rewrite this as one single logarithmic quantity, base 3, x to the 4th, x plus 5 to the 4th, over x minus 5 squared. I didn't create any problems that we had a subtraction and then an addition, okay? But let's just think for a minute, if for letter B, the signs were different. You'd have a minus here and then a plus here. Let's just think about what would happen in that case. What would go on the top, what would go on the bottom? Well, if they had a minus sign here and a plus sign here, then the two terms with the plus in front would end up being the top, and the term with the minus in the bottom. So don't think that just because the minus sign comes second, that it automatically makes the next one in the bottom as well. Okay, just the logs that have plus signs in front go in the top, and the logs that have minus signs in the bottom go in the bottom. Now likewise, if I had a minus sign in front of the log y, but parentheses or brackets around both the natural log y and the natural log x minus 3, then that means the whole thing in parentheses will go in the bottom. So because it's a plus, you can have a multiplication in the bottom. So keep that in mind as you work with these types of problems. Okay, here's your chance to check your understanding about what we just did in those last 4 examples. So rewrite this whole natural log quantity as one single logarithmic quantity. Alright, thank you for watching the video up to this point, and you have your assignment in your textbook. You may begin working on it now. Tomorrow in class I'll go over any questions that you have.